The sun bled across the Belgian plain in May 1940, a rising star of war illuminating the sheer overwhelming speed of an army unbound. Near the historic, crucial choke point of Sedan, Oberst Heinz Guderian did not concern himself with the thickness of his armor or the caliber of his gun. He concerned himself solely with tempo. Guderian, the visionary of the Blitzkrieg, understood that the ultimate weapon was not a heavier shell or a more complex machine, but the velocity of decision. His early Panzer tanks, the light Mark I and the Skew, and even the more capable Mark III, were often technically inferior to their French and British counterparts, outgunned and sometimes even outarmored. Yet they possessed one overwhelming advantage. They moved. They bypassed resistance, fractured supply lines, and operated with a ruthless, continuous momentum. The immediate ironic scenario was that Germany was winning the war of doctrine, not the war of metallurgy. This, then, establishes the unyielding thesis of the conflict. While Germany had mastered the doctrine of war, the United States, operating in a wholly separate sphere, was meticulously, relentlessly mastering the mathematics of war. The German focus, born of their tactical success, remained fixed on the standoff range and the lethal efficacy of the static duel. An armored engagement, in their minds, followed a predictable, almost chivalrous code. The vehicle would halt, the gunner would settle his sights, the range would be calculated meticulously, and the resultant projectile would strike with lethal surgical precision. The philosophical foundation of their superb 88mm gun was its capacity for precision at vast distances, a concept that only made sense if the target and, crucially, the shooter were stationary. German engineers, their voices tinged with a confident, often mocking derision, dismissed the idea of fire on the move as an extravagant technical impossibility, a futile pursuit of a marginal advantage. They scoffed, believing with a certainty born of martial tradition that any truly competent tank crew would inherently understand the necessity of stopping to deliver a kill shot. Attempting to fire a high-velocity projectile while simultaneously traversing rough terrain was considered an amateur's gambit, transforming the projectile into a mere flying milk bottle. The very idea was rhetorically unsound in their precise calculus. Yet 3,000 miles across the black, cold expanse of the Atlantic, the calculus was entirely different. The American requirement was born not of the swift, elegant maneuverings of a Panzerkeil, but of the relentless, inevitable logistics of the assembly line. The M3 Lee and its eventual successor, the M4 Sherman, were not conceived as technically superior killing machines, but as mass-producible, field-repairable, standardized platforms capable of being manufactured in volumes that dwarfed Germany's total industrial output. The contrasting visual elements spoke volumes. The sleek, intimidating, but resource-intensive silhouette of the Panzer III, built by skilled artisans, versus the corpulent, box-like frame of the M3 Lee, a lumbering behemoth that was the very symbol of American mass production necessity over aesthetic design. To the Americans, the technical challenge was not how to make the tank better, but how to make the average, less trained, factory floor shipped gunner more effective, faster, and more often on the battlefield. This nascent pragmatic requirement led not to the elite design labs of specialized arms makers, but to the seemingly mundane offices of a company known for stabilizing the world's navies and airlines. Here, the story introduces the trivial detail that would become cosmically significant: the forgotten engineer, an anonymous but brilliant individual working for a firm like the Sperry Corporation. His current task was not tanks, but the far less glamorous technical challenge of solving the problem of vibration in naval anti-aircraft mounts. Anti-aircraft fire required a gun that could hold its elevation true, independent of the ship's violent pitch and roll in heavy seas, a system of pure physics and controlled inertia. The challenge was to maintain a stable firing platform while the world around it violently changed. This man, applying the principles of the ship's gyroscope, a simple, high-speed, spinning wheel, had already perfected a mechanism for counteracting the chaotic forces of the ocean. He was working on a vertical stabilization system that could hold a gun steady against the movement of a 40,000-ton hull. To him, a 20-ton tank traversing a small ditch was simply a smaller, land-bound, and far less complex problem of pitch and yaw. The thesis was about to be proven. American industrial supremacy would not be a spectacular single invention, but the brilliant unsung application of existing mass-producible technology to the core logistical problem of warfare. The hum of this gyroscope, an engine originally designed to steady guns against the waves, was about to become the quiet, rhythmic beat of the mathematics of destruction. The two adversaries approached the industrialization of conflict with philosophies so fundamentally opposed they seemed to be waging two different wars. For the German High Command, the enduring mantra was the tyranny of precision, a devotion to engineering dominance where the metric of success was the quality of the single, flawless artifact. The apotheosis of this doctrine was the 88mm anti-aircraft and anti-tank gun, a weapon so finely calibrated, so meticulously machined, that each example required thousands of man-hours of skilled labor, consuming vast quantities of rare, strategic alloys and demanding inspection standards that would have crippled any high-volume factory. This pursuit of standoff perfection led inexorably to the design of vehicles like the Tiger and Panther tanks, superior, intimidating machines built with overlapping complex armor plates, sophisticated Maybach transmissions, and main guns that could strike from distances previously considered impossible. They were masterpieces of engineering, but they were also profound, devastating liabilities in the context of a total war demanding industrial volume. The statistical reveal of this philosophy's inherent failure is a cold, hard number. The total production of the vaunted Tiger I tank reached only approximately 1,355 units. Each one was a spectacular hammer, but the enemy was an avalanche. Conversely, across the ocean, the American effort embraced the workshop of democracy, where the metric of success was not the individual unit's quality, but the velocity of the production line. The American philosophy was one of mass production dominance, a belief that unlimited resources were, in themselves, the ultimate military weapon, a thesis that would be proven not by the lethality of a single shell, but by the overwhelming, suffocating quantity of shells fired. The M4 Sherman medium tank was the physical embodiment of this idea, a vehicle designed not by tank men, but by engineers focused on simplicity, reliability, and standardization. It was deliberately unsophisticated, built with flat, easily welded plates, powered by readily available radial aircraft engines, and capable of being assembled by semi-skilled laborers in converted automobile plants across the nation. The numbers stand as an unassailable, data-supported conclusion of this strategy. The final production count of the M4 Sherman approached nearly 50,000 units, a number so astronomically large it renders the German effort historically insignificant. This was the mathematics of war made manifest. For every single Tiger that rolled onto the battlefield, America could deliver nearly 37 Shermans. It was within this context of overwhelming logistics that the humble anti-vibration technology, conceived by the forgotten engineer, transitioned from a mere technical curiosity to a non-negotiable strategic requirement. The decision to incorporate the gyroscope-based stabilizer was driven less by the romantic narratives of frontline combat reports and more by the cold, unforgiving demands of the supply chain. The problem was one of efficiency and waste. A tank that stops to fire consumes precious seconds and exposes itself to counterfire, but a tank that fires on the move is hopelessly inaccurate. The difference between the two states was not merely tactical, it was logistical. A 5-degree pitch change in a Sherman traveling at a modest 15 miles per hour over typical European ground translated directly into a devastating 200-foot miss at a 1,000-yard engagement range. This was not a minor inconvenience. It was the difference between a high-explosive round hitting a target and becoming a wasted unit of industrial effort, a squandered shell, a gallon of fuel burned for nothing. The visceral reality for the crewman inside an unstabilized tank was one of pure, nauseating violence. Every rut, every broken stone, translated into a sickening, vertical jolt that made the act of sighting a target a perverse form of torture. The gunner, pressed against the rubberized face pad of his telescope, felt the tank's every movement amplify into a whip crack that could nearly lead to the crewman's neck snapping against the sight, his vision blurring from the concussion of the vehicle's erratic motions. The air would fill with the acrid scent of a near miss caused not by enemy fire, but by the unpredictable movement of his own gun. The stabilizer, therefore, was not introduced to achieve perfect accuracy. It was incorporated to reduce the miss rate to an acceptable, logistically tenable level, allowing the gunner to maintain his azimuth and rough elevation while the tank was still moving towards the fight. It was a trade-off, a slight reduction in maximum static precision for a vast, overwhelming increase in the volume of fire delivered on the move. The forgotten engineer, laboring in the quiet halls of American industry, committed an act of intellectual heresy. He took the sophisticated technology designed to fight the relentless chaos of the sea and applied it to the brute chaos of the land war. This was the genesis of the system, a narrative-driven technical deep dive into a mechanism whose elegance lay in its sheer, uncompromising pragmatism. The technical heart of the Sherman's unexpected lethality was not a bespoke, purpose-built military apparatus, but a clever adapted version of the naval anti-aircraft fire control gyroscope, a simple machine originally intended to track aircraft while the deck beneath it heaved and plunged. This was the slow-burn exposition that proved the thesis of industrial resourcefulness. The specific mechanism that would eventually define the M4's tactical advantage was a small, brutally effective unit, the Sperry Mark 18 vertical stabilizer, or its functional analog. Its genius resided in its singularity of focus. It weighed mere hundreds of pounds, a trivial addition to a 30-ton vehicle, and consumed a minimal trickle of the tank's copious electrical power. At its core was a high-speed gyroscope, its mass held in a rigid frame, programmed by its inherent physics to resist any change in its plane of rotation. This rotor, a marvel of small-scale engineering, achieved a dizzying gyro spin of 20,000 revolutions per minute, generating a powerful inertial resistance to the chaotic movements of the hull around it. When the tank encountered a bump, a depression, or a braking force, the hull would pitch violently up or down. But the gyroscope, maintaining its absolute plane, would instantly detect this deviation. This detection was then translated through a simple but robust mechanical linkage to the gun's hydraulic elevation system. Here, the precise, overwhelming data points define the system's terrifying efficacy. The link triggered a servo mechanism that injected hydraulic fluid at 2,000 pounds per square inch into the gun's pistons, forcing the barrel to instantaneously counteract the hull's motion. If the tank pitched 5 degrees nose down, the stabilizer simultaneously forced the gun barrel 5 degrees upward, ensuring the gun tube, and critically, the gunner's optic, remained fixed on the original target plane. This entire operation occurred within the microfractions of a second necessary to counter the vehicle's pitch, operating across a functional stabilization arc of plus or minus 4 degrees. The purpose was not, and must be clearly understood as not, to aim the gun. It was to hold the plane of fire constant during moments of dramatic dynamic change, specifically during acceleration, deceleration, and pitch. The system achieved a total cancellation of the vehicle's chaotic vertical motion, removing the primary variable that had historically forced armored crews to halt before engaging. The gunner was, by this technical trickery, taken out of the tank's violent environment and placed into an independent, stable microcosm of his own. The resulting effect, rendered through metaphor and analogy, was like strapping the gunner's optic to a locomotive that is simultaneously riding a flying carpet. While the chassis beneath him bucked and jarred its way across the torn earth, the massive 30-ton gun barrel remained eerily level, its sight picture bobbing only minimally. The gunner was now free to focus exclusively on two remaining factors: azimuth, the lateral traverse, and the final, minute fine-tuning of elevation that every gunner must perform. The gyroscope did the difficult, physics-defying work of fighting gravity and momentum. The man merely had to choose the moment to pull the trigger. It was a trade-off that was fundamentally American, sacrificing the theoretical perfection of the static kill for the brutal statistical reality of the moving hit. The stabilizer was the essential piece of hardware that made the mathematics of destruction practical, ensuring that volume and tempo would overwhelm precision. Its constant rhythmic hum inside the turret was the sound of a technical solution applied at scale, a quiet, insistent promise of the avalanche of steel and lead to come. The war unfolded in two disparate dimensions. In the hushed, cavernous technical offices of the Third Reich, a mood of quiet desperation began to settle, one born of an inability to match Allied production, while on the vast, sun-baked proving grounds of Aberdeen and Fort Knox, American testing proceeded with a confident, almost arrogant certainty. The German engineers, burdened by the weight of their own tyranny of precision, were obsessed with the theoretical perfection of the stationary shot, refining gun barrels and optics to achieve kills at ever greater, more distant ranges. They had perfected the instrument of war. They had failed to master the logistics of war. The American effort, by contrast, was an unrelenting exercise in awe-inspiring scale and unapologetic military business history, driven not by the pursuit of the best, but by the pursuit of the most efficient. The stabilization system, the adaptation of the humble gyroscope, was subjected to a brutal, rhythmic regimen of testing. This phase of development saw the pouring of an immense, abstract figure of 200,000 hours of testing into the machine, a vast investment in industrial time focused on proving a singular economic truth. The core question was not whether the stabilizer could increase accuracy, but whether it could decrease waste. The results, a stark and irrefutable statistical reveal, were devastatingly simple. American field trials demonstrated that a stabilized Sherman traversing rough terrain at combat speed could achieve a first-round hit probability of 20% against a target at a reasonable engagement range. This was a quantum leap over the performance of an unstabilized vehicle, which, under the same conditions, rarely managed a hit probability of less than 2%. The difference was one of tactical utility versus logistical futility. The irony and the ultimate victory of the American industrial thesis was that this groundbreaking system was initially met with resistance by conservative ordnance officers. They saw the gyroscope, the hydraulic lines, and the complex electrical connections as an expensive complication, an unnecessary component that would increase maintenance and failure rates in the field. They clung to the old conventional wisdom: a tank must stop to fight. The forgotten engineer's invention was saved not by a daring frontline pilot's report, but by the cold, unforgiving metrics of the business case. The analysis presented to the skeptical hierarchy was simple and irrefutable, proving the thesis that logistics and economics were the ultimate weapons. If an unstabilized tank required a minimum of 10 shells fired after halting, aiming, and correcting to achieve a high probability of kill, a stabilized tank required, statistically, only 2 rounds fired on the move to achieve the same or better result. The equation was clear. A moving tank firing 2 rounds was logistically more efficient than a stopped tank firing 10. The reduction in wasted ammunition, the reduction in time spent exposed, and the exponential increase in the volume of effective fire delivered by a unit on the attack translated directly into saving millions of rounds of 75mm ammunition, thousands of gallons of high-octane fuel, and countless man-hours of production. The cost per hit became the decisive, unassailable factor, demonstrating that the stabilizer was not merely a technical improvement, but an industrial imperative. This was the difference between aiming for the perfect, singular strike and embracing the overwhelming power of continuous, sustained pressure. As a single, frustrated American lieutenant was, perhaps apocryphally, quoted as saying, capturing the sheer, visceral contrast, "It's the difference between trying to shoot a pheasant with a rifle and just hosing the air with an automatic shotgun." The Rhino, as the Sherman was sometimes derisively nicknamed for its sturdy, blocky shape, was not going to win a contest of precision at 1,000 yards. It was going to win a contest of delivered force at close quarters, relying on its ability to maintain a continuous moving torrent of lead and steel, an avalanche that would smother the Germans' reliance on the static, decisive kill. The crucible was the desert, the harsh, unforgiving sands of North Africa, a theater where mechanical endurance and professional training had long consecrated the German Africa Corps as masters of armored warfare. The time for the turning point had arrived. November 1942. A new wave of American crewed M4 Shermans, fresh from the endless production lines of the American industrial heartland, was rolling across the dusty plains, and the encounter was a collision not merely of steel, but of two utterly irreconcilable philosophies of combat. The scene is set with a precise, cinematic buildup. We watch through the eyes of two anonymous figures who serve as rhetorical foils for the central theme of industrial capacity. Obergefreiter Klaus, a panzer grenadier with the 15. Panzerdivision, anchored by the unwavering belief in the technical superiority of the German machine, and Sergeant Miller, an American tank gunner whose training was as standardized and efficient as the vehicle he operated. Klaus watched the approaching American column from a ridge near the faint winding track that led towards Tunisia. He smiled, a thin, knowing expression shared by his veteran comrades. The American tanks were fat, clumsy milk bottles, their high profiles and perpendicular armor, a testament in his mind to the incompetence of the American amateurs and the overwhelming strategic advantage of the German commitment to precision design. His unit had faced the British Matildas and the Crusaders, solid, predictable adversaries who adhered to the expected rhythms of armored combat. Their own column of Panzer IVs, their crews veterans of years in the desert sun, moved with a practiced, predatory confidence, adhering to the ingrained, unshakable halt and fire doctrine. The battle was already won in the theoretical space of their training. They knew how to fight, and they knew the Americans did not. This initial derision was the ironic foreshadowing of the sheer, unadulterated terror to come. The distance closed rapidly. The German commander, a man whose voice was rasped by desert dust and experience, gave the familiar, non-negotiable command, "Halt, Feuerbereit." The column of Panzer IVs slowed, ground to a decisive halt, and the tanks settled on their suspensions. Gun sights were rushed into position, the gunners' heads pressed against the optics, awaiting the final, tiny corrections that would ensure a surgical kill. They had the range, the armor, and the experience. They had done this 100 times before. This was the expected, civilized pace of armored engagement, a duel of meticulous calculation. The Americans, of course, would now stop, survey the field, and prepare their own inferior response. But the pacing accelerates dramatically. The American Shermans did not stop. They did not slow to a crawl to settle their sights, nor did their commanders expose themselves unnecessarily to calculate lead and deflection. They kept coming, still moving at combat speed, a shocking, heretical violation of every tenet of armored warfare known to the Wehrmacht. Sergeant Miller, his hands steady on the gun traverse wheel, was experiencing the silent miracle of the forgotten engineer. The tank beneath him pitched and yawed as it crossed the broken ground, but the small, humming gyroscope in the turret relentlessly forced the 75mm gun to counteract the vehicle's motion, holding his reticle on target with uncanny, almost supernatural stability. He didn't need to stop, he only needed to track. Before the German gunners could fully settle their fine-tuned sights, before they could even finalize the range calculations necessary for their precision strike, the Shermans unleashed a devastating, coordinated fire. The desert air was torn apart by the thunderclap of multiple rounds exploding in rapid succession. The initial German reaction of laughter and patronizing scorn dissolved instantly into a paralyzing fear. They had been robbed of the critical 10 seconds required for their standoff engagement, the time necessary to convert their superior static precision into a battlefield reality. They had stopped making themselves perfect, high-contrast targets, while the amateur Americans, utilizing the industrialized genius of the vertical stabilizer, had transformed the mathematics of the duel from a precision competition into an avalanche of steel and lead. The first German Panzer IV lurched to a halt, a catastrophic plume of black smoke erupting from its engine deck, struck not by a perfectly aimed round, but by the overwhelming, continuous volume of fire delivered by a force that refused to obey the conventional laws of physics and warfare. The element of surprise was absolute. The terror was immediate. The blinding sunlight of the Tunisian valley, specifically the infamous pass at Kasserine, became the unwelcome stage for the climax at the midpoint execution, a key human event that irrevocably shifted the narrative focus of the war from technical design to strategic consequence. The air itself seemed to vibrate with a tension that was not merely combat dread, but the profound shock of facing an enemy whose conduct on the field violated every established tenet of armored engagement. Hauptmann Hermann, a German tank ace whose confidence was forged in the fire of countless engagements, watched the unfolding scene in a state of utter, frozen disbelief. His perspective, now the third-person limited anchor of the chaos, was that of an expert watching his entire professional philosophy disintegrate in seconds. Hermann saw his comrade's column of Panzer IVs, superior in optics and gunpowder, execute the necessary maneuver, the decisive stop, the settling of the suspension, the fine-tuning of the sights. This was the moment of German supremacy, the juncture at which their precision engineering was supposed to deliver the decisive kill. But the Shermans, those fat milk bottles so easily mocked in the pre-battle analysis, refused to play by the rules of the duel. They continued to advance, their 75mm guns spitting flame even as the hulls pitched and rolled over the broken wadis and scrub brush. Hermann watched, dumbfounded, as the American tanks executed a maneuver he had only dismissed as a fantasy. A devastating, effective fire-on-the-move sequence, delivering rounds at ranges that, by the laws of physics and gunnery he knew, should have been impossible from an unstabilized traveling platform. The stabilizer, the gyroscope that was the ultimate product of American industrial logistics, allowed the Shermans to achieve a terrifying tactical miracle. It was not a tool of pinpoint precision, but a survival multiplier. The first German panzer to halt was met not with a single aimed shot, but with a continuous overlapping volley from multiple American vehicles, none of whom had ceded their momentum or exposed their vulnerable, stationary positions. The visceral and sensory descriptions of the impact were immediate and overwhelming. A thunderclap of a 75mm high explosive round struck the turret ring of a lead Panzer IV, vaporizing the optics and instantly immobilizing the crew. The terrifying realization struck Hermann with the force of an anti-tank shell. The Americans did not need to be better shots. They simply needed to be first. They had made a calculated industrial trade-off, accepting a slight, marginal drop in theoretical accuracy in exchange for a vast, unrelenting increase in rate of fire and survivability. They were prioritizing tempo over exactitude, and it was devastatingly effective. The result of the engagement was a revelation that rippled back through the German command structure, forcing a brutal reevaluation of the entire industrial war effort. A German field report, perhaps embellished but entirely capturing the strategic shock, was said to have summarized the new, terrifying reality. The statistical reveal was stark, simple, and paralyzing. They were engaging us while turning. The typical 20-second advantage we required for our first shot was eliminated. They had simply transformed the engagement into a pure numbers game. The true value of the stabilization system was finally understood. It was not a precision tool designed to put a round through a commander's periscope. It was a device of economic warfare, a technical cheat that allowed mass-produced crews to deliver a lethal volume of fire while denying the superior, but slower, German machines the time and space needed to bring their tyranny of precision to bear. The war, which Germany had defined through the meticulous quality of its steel and the supreme training of its crews, was now being ruthlessly redefined by the American capacity to flood the battlefield with a continuous, moving avalanche of steel and lead. The stabilization system was the single, humble mechanism that proved the core thesis. Logistics triumphs over brilliance, and the mathematics of defeat had begun its relentless calculation. The blinding shock of Kasserine Pass gave way to a cold analytical horror within the German High Command, a dawning comprehension that their technical supremacy had been strategically negated by the sheer unyielding force of industrial capacity. The narrative now pivots to this devastating strategic consequence, proving the thesis of the war's true nature relentlessly. German engineers, once so quick to mock the clumsy appearance of the Sherman, now acknowledged the devastating tactical reality of the American stabilization system. They understood the principle, a gyroscope counteracting pitch, but found themselves staring at the grim, insurmountable wall of production velocity. Their reaction was agonizingly slow and inadequate, a consequence of a fundamental flaw in their entire industrial philosophy. Having dedicated years to the tyranny of precision, the German war machine was configured to build singular, sophisticated masterpieces like the Tiger II, a behemoth of armor and firepower that demanded meticulous tolerances, thousands of man-hours, and consumption of scarce, high-quality materials. Their factories were, effectively, strategic collections of workshops, incapable of the rapid wholesale retooling necessary to incorporate such a standardized, high-volume component. To attempt to retrofit their existing Panzer fleet or build 50,000 gyroscopes to match the American output would have meant halting the production of almost every other essential piece of complex weaponry, a politically and logistically impossible decision. The result was that the mathematics of defeat began to beat with a terrifying rhythmic constancy. Every stabilization unit that rolled off an American assembly line was not merely a mechanical component. It was one more piece of a relentless avalanche that Germany could neither halt nor match. The German design philosophy, a fatal focus on complex optical sights, heavier, thicker armor, and guns of ever-increasing caliber, is shown to be a profound strategic error because it ruthlessly sacrificed tempo and volume. They had engineered a magnificent weapon for a duel, while the Americans had engineered a mass-producible system for a slaughter. The juxtaposition of scales provides the final, damning evidence. Consider the logistics of the stabilizer. A single gyroscope factory in New York, a seemingly minor contractor in the grand scheme of the American war effort, was capable of producing more stabilizer units in a week than the entire German tank industry was producing finished tanks in a month. This staggering disparity was the difference between a fully optimized national industry designed for interchangeable parts and ruthless efficiency, and a decentralized, strategic collection of workshops plagued by bespoke parts, over-engineering, and the constant drain of skilled labor. The Sherman's vertical stabilizer was not a Wunderwaffe, a miracle weapon. It was a simple, common, and most importantly, mass-producible adaptation of existing technology. It was the epitome of the American approach, a simple solution deployed at a devastating scale. This relentless repetition of industrial capacity underscored the truth. The stabilized Sherman was not just a better tank, it was a better system. It allowed a less trained crew to fire effectively while maneuvering, translating the endless volume of American production into usable battlefield force. The German reliance on the highly skilled lieutenant with his precise instruments and superior standoff gunnery was now a fatal liability, easily overwhelmed by the endless wave of American armor whose crews, though less polished, could now deliver a continuous, moving torrent of fire. The stabilizer ensured that the superior quality of the German machine was nullified by the sheer, overwhelming quantity of the American response, turning the tank battle into an equation that Germany could not solve. They had sought technical mastery. They were being crushed by logistical inevitability. The integration of the humble vertical stabilizer did more than merely improve the Sherman. It fundamentally, irrevocably changed the American armored doctrine, carving out a new, aggressive form of combat based on controlled chaos. This chapter of unapologetic military history reveals the full, devastating potential of the forgotten engineer's work. With the ability to fire effectively while maneuvering, the American command abandoned the European obsession with armored duels and static protection, instead fielding specialized vehicles whose entire mission was predicated on mobility and volume of fire. The stabilization system was the technical key that unlocked the true strategic purpose of the tank destroyer force. Vehicles like the M10 Wolverine and, more dramatically, the M18 Hellcat were designed as fast, open-topped hunters, trading the Sherman's modest armor for breathtaking velocity. The doctrine was simple and brutal. Never stop, always flank, and overwhelm the static German heavy tanks with a torrent of moving fire. The stabilizer was essential to this concept. Without it, the Hellcat's furious speed would have rendered its 76mm gun useless, turning the high-velocity gun into a mere liability during the crucial moments of engagement. Instead, the tank destroyer crews learned to dance with their vehicles, using the stabilizer to maintain their sights with uncanny precision while executing wild, high-speed flanking maneuvers. The M18 Hellcat became the spectacular embodiment of this doctrine. A deep dive into its specifications reveals the sheer audacity of its design. Its 500-horsepower radial engine drove a chassis designed for speed, not protection, allowing it to achieve an almost reckless velocity on the battlefield. Its high suspension, while making it a visual target, was engineered to devour ground rapidly. With the gyroscope humming in the turret, its commander could exploit that speed, closing the distance and delivering its 76mm round on target while the vehicle was still accelerating. The stabilizer transformed the Hellcat's theoretical mobility into a brutal battlefield combat reality, making the tank destroyer an elusive, continuous threat that defied the German preference for long-range, static engagement. The rounds fired by these stabilized hunters were not surgical strikes. They were described in evocative language as hammers from heaven, part of a continuous, overwhelming pressure that broke the German spirit as surely as it broke their steel. The Americans utilized the stabilizer to maintain a high volume of effective fire, disrupting the German gunners' concentration, damaging external equipment, and forcing the superior German tanks to fire while moving, which for their unstabilized platforms meant near-certain misses. The Sherman, that much maligned machine, was only a flying milk bottle in its exterior appearance. Its true function was that of a mobile, high-volume dispensing unit for lead and steel, a truly terrifying prospect for a static enemy. The stabilizer ensured that the superior German armor could never rest, never truly set its sight, and was constantly forced to react to a threat that was simultaneously closing in and striking with effective, continuous ferocity. The war had become an exhausting asymmetrical chase, where the American industrial output was translated into unrelenting tactical speed, and the stabilizer was the machine that made that speed lethal. The victory forged by the gyroscope was not without its terrible, commensurate human cost, a somber acknowledgment that must temper the narrative of industrial triumph. While the vertical stabilization system dramatically increased the Sherman tank's combat efficiency, allowing the American war machine to deliver a devastating volume of fire on the move, it simultaneously and ironically exposed the crews to greater risk. The system was designed to increase safety by reducing the time spent stationary and vulnerable. Yet, by granting the crews a profound, game-changing advantage in tempo, it actively encouraged them to push the envelope of tactical safety, engaging the superior German heavy tanks at close quarters where their massive guns could more easily penetrate the Sherman's hull. This was the core irony of the American fighting doctrine. The brilliant technical solution led directly to a statistical dance with death. The Sherman's relatively thinner armor, an unavoidable byproduct of the overriding American mass production philosophy, meant that every exchange with a German Tiger or Panther was a brutal calculation of probability. The American crew's advantage was not the ability to withstand a hit, but the ability to deliver the first decisive round, or more accurately, the first continuous stream of rounds. The stabilization system was the only mechanism that tipped the scales of that deadly exchange, as captured in the imagined yet wholly accurate reflection of a battle-hardened Sherman crewman. The words, stripped of any pretense of glory, cut to the cruel simplicity of the tactical trade-off. It was a trade. We knew we were meat for the slaughter if they hit us first. The stabilizer just meant we got to shoot first more often. It was the only thing that made the difference between a 40-ton funeral pyre and living to see tomorrow. The stabilizer was not a shield. It was a tool for seizing the initiative, a necessary prerequisite for survival when facing a foe whose weapon and armor were categorically superior. The forgotten engineer's creation thus became the ubiquitous standard that allowed a generation of less trained, mass-produced crews to fight on equal and often superior terms with elite German veterans. By 1945, the statistical finality of this industrial conversion was absolute. Over 80% of all American medium tanks serving in the European theater were equipped with the vertical stabilizer. This represented not merely a technical advantage, but a complete strategic conversion. It meant that the United States had successfully homogenized the skill required for armored combat. The stabilizer compensated for the inevitable variance in crew training that occurs when producing a massive army, ensuring that every Sherman that rolled off the assembly line possessed the fundamental inherent ability to deliver effective fire while moving. The genius was in the standardization, the application of a single, simple component to multiply the tactical efficacy of tens of thousands of vehicles. The technical advantage, conceived in a quiet workshop by a man whose name history would largely forget, became the foundational reality of the Allied ground effort. It was the crucial technical lubricant that enabled the machine of unlimited resources to operate at maximum efficiency, transforming the continuous flow of American steel, oil, and manpower into a continuous flow of effective combat fire. The ultimate, profound irony of the American war effort resides in the final analysis of the vertical stabilizer. Its true secret was never its technology at all. It was not the brilliance of the gyroscope, which was a known commodity, nor the complexity of the hydraulic linkage. The secret was the industrial philosophy that allowed this technical solution to be mass-produced and standardized at a rate that annihilated the enemy's best-laid plans. This narrative returns finally to the forgotten engineer, the anonymous figure in the quiet workshop whose name is ultimately irrelevant. His personal identity is consumed by the very scale of the industrial machine he served. His work is the testament to the ultimate American weapon, Not a single tank, but the velocity and volume of the assembly line. The stabilizer was not a Wunderwaffe, a fantastical miracle weapon sought in vain by the German High Command. It was simply a pragmatic engineering solution to a complex problem, deployed at a scale that transformed a tactical advantage into a crushing strategic weapon. The scale of this logistical behemoth is best grasped through the overwhelming numbers of the final statistical reveal. By the cessation of hostilities in 1945, the United States had produced over 100,000 tanks and armored vehicles and, in a demonstration of its total capacity, manufactured over 1.8 billion gallons of aviation fuel, a deluge of energy and materiel that the Axis powers could never hope to approach. The stabilizer, a simple spinning gyroscope, was a micro-component, a fractional piece of hardware within this tsunami of production. Yet its very presence in 40,000 Shermans, a standardized, ubiquitous advantage across the vast majority of the American armored fleet, was the final, irrefutable proof of the central thesis. The war was not won by the best tank, but by the best system of production and logistics. Germany had pursued the qualitative edge. America delivered the quantitative flood. The effect of this standardized system was to rewrite the rules of the battlefield with absolute finality. The stabilizer ensured that for every German tank, such as a Panther, that halted, exposing its less armored side and consuming precious seconds to fire a precise, well-aimed shot, there were 3 American Shermans bearing down on them, firing a continuous, overwhelming avalanche of steel and lead without ever breaking stride. The German technical supremacy, the superior armor, the more lethal gun, was systematically drowned in the unlimited resources of the American machine, which translated economic power into lethal battlefield tempo. The American crews could accept a lower probability per shot because they could fire exponentially more effective shots than their stationary, technically superior adversaries. The true genius of the system lay in its simplicity and its capacity for mass deployment. It was the quintessential American solution, complex enough to solve the physical problem, yet simple enough for rapid installation and standardization across entire production runs. It guaranteed that the most important commodity on the battlefield, the ability to shoot first and maintain momentum, was available to every single crew, every single time. The war ended not with the spectacular, decisive bang of a superior German gun, but with the constant, rhythmic, and strategically terrifying hum of the gyroscope emanating from 40,000 Shermans across Europe, a quiet, insistent engine of tactical and strategic victory that finally silenced the laughter of the German High Command. The industrial capacity had delivered the final, undeniable verdict.